All right, my friends, guess what today is? Today is Trig Word Problems Day. As long as you understand everything about our trig ratios that we have been practicing with, then you should be good to go. We're just going to have to draw the triangle based on what the situation says in the word problem. All right, let's look at leaning a 16-foot ladder against the wall. And I told you when we did word problems with Pythagorean theorem that the ladder is usually going to be the hypotenuse because it's usually leaning up against something that makes a right angle. Usually we have the ground and a building or something, and so the ladder is usually at a diagonal. All right, so we have a 16-foot ladder. I'm going to go ahead and mark that this ladder is 16 feet. And it forms an angle of 61 degrees with the ground. So let's think about where that 61 degree, if it forms the angle with the ground, where would that measurement be? The 61 degree angle would be down in this corner because that's the angle it makes with the ground. So now we have the length of a leg and we have an angle, and actually we have the length of a hypotenuse and an angle, and all we need is one side and one angle if we know our trig ratios to be able to find everything else that we need to know and to find all the other sides and angles of the triangle. So let's see, this question asks, how high up the wall? So you're going to have to think about which part of the triangle it is asking for if it's asking how high up the wall. Is that going to be this leg or this leg? If we're looking at how high up the wall, that's going to be across from the angle it makes with the ground. So from how I labeled it, that would be the leg I called A. So we need to find, or we're given an angle. That means we're going to use the ratios in either sine, cosine, or tangent, not the inverse ones. All right, and we have the opposite and the hypotenuse, or we're trying to find the opposite and we have the hypotenuse. So which one of the trig ratios should we use for opposite and hypotenuse? We're going to use sine. So what equation am I going to set up for sine? I'm going to do that sine of 61 degrees. Remember, we have the angle coming after sine, equals opposite, you can call that x or whatever you want to call it, over the hypotenuse, which is 16. After that, what could you do to solve it? You would multiply both sides by 16 to get rid of the dividing by 16, and then you could type this in to the calculator or the Desmos calculator and make sure you round it correctly. You got to be careful about rounding for these. This one was asking how high up the ladder reaches, but you also are going to have some that say what is the horizontal distance between the base of the ladder and the wall. Okay, so when it asks you for the horizontal distance between the base and the wall, that would be this leg down here. So that would be adjacent to the angle that the ladder makes with the wall. So you're going to have ladder questions that ask you how high up the wall it reaches and how far from the base, the horizontal distance. So be careful about which side of the triangle you are finding. All right, here's another type of question. It says, Serenity wants to use a sheet of fiberboard 22 inches long, and we want the skateboard ramp to have an angle of elevation of 25 degrees. What is angle of elevation? I put a note for you on your notes here. That's going to be the angle above a horizontal line that something makes with the ground usually, or the angle to look up. So we're going to have a skateboard ramp. This is going to be the fiber board. That's what she's using to make the ramp. So that's going to be 22 inches long. And we're looking at the angle that it makes with the ground. She wants that to be a 25-degree angle of elevation. So again, angle of elevation is usually going to be what angle something makes with the ground. So when we're working with these, we're usually going to have a right triangle. So this is going to be the right triangle here, and it says, how high will the ramp rise from the ground at the farthest end? So we're thinking about this right triangle here, and my right angle would be right here. And when it's asking how high will it rise, is that going to be asking for this leg or this leg? That would be asking for this leg right here because it says how high at the highest end. Leg A would represent the ground when the ramp ends. So let's think about if I want to find side B here, that would be the opposite side from the reference angle that it gave us. And then the skateboard ramp itself is the hypotenuse. So that means we would want to use our ratio that involves the opposite and hypotenuse again. All right, what formula could you set up to solve this? So we're going to use sine because it's opposite over hypotenuse. Sine of the angle measure, which is 25 degrees, equals the opposite over the hypotenuse. And then to solve for x, what could I do? I would just multiply by 22 on both sides. Then you have what you can type into the calculator. 22 times the sine of 25 degrees is going to give me the length of this leg here. You would need to round to the nearest tenth. Okay, let's look at some more examples. A boat is headed towards a lighthouse whose beacon light is 114 feet above the water. So I know I have a lighthouse here. I am not a good lighthouse drawer, unfortunately. And the light is 114 feet above the water. So that would mean that the lighthouse, how tall it is 114. Okay, the boat's crew measures the angle of elevation. So this boat is down here in the water, and we're looking at the angle of elevation to the beacon light. Okay, so we've got the water here, and then I've got the angle of elevation, which is only 5 degrees. That's a very small angle, I would say. And it says, what is the ship's horizontal distance from the lighthouse or the shore? So let's think about which leg this wants me to find. Does it want me to find this leg, or does it want me to find the hypotenuse for the distance to the shore? When it says horizontal distance, that's usually going to be our flat line that represents the ground, or in this case, the water. So that's the horizontal distance. Then I've got my 114 is my opposite side from the reference angle. And then the leg I'm trying to find is what? That would be the adjacent side. Okay, so let's set up our proportion. Which ratio do we use for adjacent and opposite? I'm going to use the tangent ratio. The tangent would be the opposite over adjacent. So tangent of 5 degrees is opposite over adjacent, which we're trying to find. And we talked about how you could just, if your variable is on the bottom, you can always just flip that around. I could flip the x and the tangent of 5 degrees to type in and get my horizontal distance here. So guys, the key with this is you really want to draw a right triangle, figure out what each leg and the hypotenuse represents in each situation. All right, let's look at one that has an angle of depression. Madison is on the observation deck of a skyscraper. So this is going to be my skyscraper. And from the observation deck, Madison measures a 76-degree angle of depression. So the angle of depression is going to be the angle from a horizontal line going down. So that's not, the angle of depression is a little bit trickier. That's not going to be this angle here. That's not the angle of depression. The angle of depression would be from a horizontal line. So that would be 67 degrees. Okay, the angle of depression is from a horizontal line. So it would not be this angle here. All right. The observation deck is 1143 feet, so that's how high this is. And it wants us to find the horizontal distance, that's usually going to be our flat line, from the base of the skyscraper out to the boat out in the water. All right, you can see we have our right triangle here. And this is the side we're trying to find here. But we only have one side length for this triangle. We do not have any angles for this specific triangle. So what we're going to have to do is get creative. There's a couple things you could do. One thing that you could do is find this angle here, based on the fact that this would form a right angle. Something else that you could do is think way back to a while ago we talked about all of our different angle relationships, and anytime that we have two parallel lines, so obviously horizontal lines would be parallel to each other. Anytime we have two parallel lines and a transversal, remember we have all those special angle pair relationships. So what I can do is I can use this fact that I have parallel lines, and I could think about what some other relationships would be. All right. If I know that this angle is 67 degrees, then I also know that this corresponding angle is 67 degrees, and this vertical angle is 67 degrees, and this angle inside my triangle would also be 67 degrees. Okay, what is the relationship that we called this angle and this angle with our parallel lines and transversal? Those are alternate interior angles. So basically what you're going to do when you have an angle of depression is you've got to remember that it's not going to be inside the triangle formed with the ground, but the angle of depression is going to equal the angle of elevation. So in other words, the angle of depression from the top of this skyscraper down to the boat is the same as the angle of elevation from the boat looking up to the skyscraper. All right, let's take a look at which ratio we want to use here. This 67 degrees, if we look within this triangle, then what we're trying to find is this leg right here, which would be an adjacent leg, and 1143, which is opposite. So what formula could you set up to solve for the base of this triangle? Since we have opposite and we're looking for adjacent, I would use tangent. So tangent of 67 degrees. So from there, I'm sure you could figure it out because we've done enough of these. You just set up your ratio and then you solve to find whatever it is asking for. Let's look at a few more. The angle of elevation to a nearby tree, so we're going to have some sort of tree. I'm going to guess it's a palm tree because I like palm trees, if you didn't know. From a tree to a tree from a point on the ground. So that's just any random point on the ground, is measured to be 39 degrees. So remember, angle of elevation again is the angle above a horizontal line to look up at something. All right, so we're going to say the angle of elevation, it tells us, is 39 degrees. And it asks, how tall is the tree if the point on the ground is 82 feet from the tree? All right, so let's think about how I'm going to fill in this diagram. We've got 3 sides of a triangle here. And if it asks how tall is the tree, which part of this triangle would it be asking for? That would obviously be C because we're looking at how high the tree is. And then if it says the point on the ground is 82 feet from the tree, which side would that be asking for, or would that be giving us? 82 feet would be B because that's going to be a point on the ground and the distance from the tree is going to be your horizontal distance here. All right, same thing, you set up your proportion. This one I think would be tangent because it's opposite over adjacent. So you just set up your ratios and solve them. It's pretty basic. The hardest thing about these, I think, is figuring out which side it's giving you and which side it's asking for. So it really helps you to draw a picture, think about what would be at a diagonal, what line would be on a diagonal, what would be horizontal and vertical. And I also want you to keep in mind that Delta Math doesn't, at the time I'm making this video, it doesn't have any questions that ask you for the angle. So you will need to know how to do the ones that are asking you for an angle using inverse. Like, for example, if I gave you the height of the tree and the distance from the ground and asked you what the angle of elevation or angle of depression was, you do need to know how to solve those as well. All right, so don't stress out too much about these word problems because they're pretty simple, especially if you know how to solve like we've done the past couple lessons. And they're pretty basic. It's just you've got to figure out which part of the triangle each thing is that it's talking about.